In this problem, we're looking at the sampling distribution of the standard deviation. So in part A, it asks us to find the value of the population standard deviation sigma for our population, which is a very small population, just the numbers 1, 2, and 12. So I'm going to start by entering those values into list 1 and using one variable statistics to get the population standard deviation. Okay, I have my values in list 1, and now I've done one variable statistics, and I have the population standard deviation, which is sigma. So this is 4.966, etc. And we're going to round this to 3 decimal places. So that gives me 4.967 for sigma. Now in part B, we need to find the standard deviation of each of the 9 possible samples from the original population of our 3 numbers. And then we're going to summarize the sampling distribution of the standard deviations in the table that they give us. So in order to do this, what I'm going to do is make a kind of a separate table of my own where I can find all of these standard deviations, or at least not so much find them as record them. So keep in mind that now we're looking at the sample standard deviation, not the population standard deviation, because we're taking little samples. So I'm going to start with numbers that are easy to do. Rather than having to enter these into the calculator, I realized that if we're looking at a sample of the numbers 1 and 1, then the standard deviation is going to be 0. It's going to be 0 because there's no variation there. It's just the same numbers. And so the same thing for 2 and 2, and the same thing for 12 and 12. So that's fine as long as the numbers are the same, but what if they're not? How do we get the standard deviation? So that's where I'm going to go back to my calculator, and I put the numbers 1 and 2 into list 1 because that's my sample, and then I'm going to run one variable statistics again. Okay, now keep in mind again that it's the sample standard deviation we're looking at here, not the population standard deviation. So since the Math Lab is asking you to find your standard deviations to 3 decimal places, we're going to have 0.707 for 1 and 2, and then it'll be the same thing here, 0.707 for 2 and 1, since of course the order isn't going to make a difference. Okay, so now I've got the values for 1 and 2 and 2 and 1. So now I'm going to go back to the calculator and I'll change the 2 to a 12 and find out, well, what's the standard deviation if I use a sample of 1 and 12. And then I'll do that for all the different pairs. So we've got 1 and 12 we still have to do, 2 and 12, well, and that's it. So just 2 more pairs that we're going to do. And I'll go through and do that on the calculator. Okay, so now I have my table filled in, and I can create my sampling distribution over here, my probability distribution. So I'm just going to select each of the values of S, and they want you to do them in ascending order. Okay, so I've got all of my values listed here, and now I have to put in the probabilities. For the number 0, since it appears 3 times out of the 9 possibilities, so that's going to be 3 over 9 or 1/3. And then 0.707 appears 2 times, so that's going to be 2 out of 9, and the other 2 are also 2 out of 9. Okay. So if you check that, you add 1/3, 2/9, 2/9, and 2/9, you get 1 or 100% of the values. So that checks out, that's correct. So we've got our probability distribution, and now we're ready for part C. I put my sampling distribution into lists 1 and 2, and keep in mind that now, since we do have values in both lists, when we do one variable statistics, we're going to need to specify that we're using list 1 and list 2. If you have the wizard, then make L1 your list and L2 your frequency list. And if you don't, then when you're typing it in, then just type in 1 var stats L1, comma L2. All right, so now that I've got that in, I run my one variable statistics, and I'm going to get these results. So now we're not looking at standard deviation because they asked us to find the mean of the sampling distribution of the sample means. So here is the mean of the sampling distribution. They want us to find the mean of the sampling distribution of the sample standard deviations. So this is our mean. So it's 3.457 rounded up. 3.457. And then when we compare that to the original value of the population standard deviation, notice that they're not the same value at all. So my original population standard deviation was 4.967. The mean of the sample standard deviations turns out to be 3.457, which tells us that the sample standard deviation does not target the population standard deviation, and so it is a biased estimator. So this is our answer to part D, which asks if the sample standard deviation is a good estimator for the population standard deviation. So it does not target the population standard deviation, which makes it a biased estimator. And that's how you do that problem.